Hi everyone, so thank you for joining this session. My name is George Constantin. I'm part of the Oracle EMEA Technology Cloud Engineering organization, and I recently joined the automation team working mainly with the Terraform. So in this session, I'm going to do an overview about the most commonly autoscaling features of Kubernetes and an introduction about how to use them in Oracle Cloud Infrastructure or OCI. It is not intended to be for advanced Kubernetes users, so today we'll be covering just the basics that may help you to get started with Kubernetes autoscalers in Oracle Cloud. My colleague will help answering your technical questions, so you can put these questions anytime in the Q&A if you have. So as you know, there are several autoscaling tools provided by Kubernetes: horizontal pod autoscaler, vertical pod autoscaler, and cluster autoscaler. There are some other autoscalers like for Kubernetes, like KEDA, Kubernetes Event-Driven Autoscaling, that I'm not going to talk about into these sessions. Now, why using autoscalers? So autoscalers can help us to optimize the resource usage and cost, and can also improve performance. Now, let's first understand the basics and see how each autoscaler works in Kubernetes. So let's assume that I have a cluster with one single node, and on top of this node I have one pod. And let's see what's happening in case of horizontal pod autoscaler, vertical pod autoscaler, and cluster autoscaler. So if during the scaling up operations, horizontal pod autoscaler is when there is an increased load, is trying to add more pods, and it split the workload across the new pods. In case of the vertical pod autoscalers, the capacity of the existing nodes is increased, so the CPU and memory is increased using the recommendations that are given by vertical pod autoscaler. In case of cluster autoscaler, cluster autoscaler is adding extra node capacity. Of course, if we are allowed to do so, it's looking for unscheduled pods. So if there are unscheduled pods and there is capacity required by those pods, cluster autoscaler will increase the number of pods, and of course the pods will be split across the entire nodes. Now the same logic applies when during the scaling down. Horizontal pod autoscaler is actually removing the nodes during the scaling up operation. The vertical pod autoscaler is actually it limits the resources allocated to the pod, so it gives less resources to the existing pods. And cluster autoscaler is actually removing the nodes that are not supposedly to be used, are not used by the pods. Now, it's important because horizontal pod autoscaler and vertical pod autoscaler are driven by metrics. It's important to see how our metrics are collected in the Kubernetes. So on each worker node, we have a small process, kubelet, running on top of the worker nodes. And CAdvisor, Container Advisor, is part of the kubelet. CAdvisor, it collects the metrics from the pods. It sends the metrics on the control plane side to the metrics server, and metrics server are accessed via the metrics API server. And replication controller, in case of the horizontal pod autoscaler, is the one that decides if to scale up or down the number of pods. Now it's sending the request to the kubelet, and kubelet scales up and down. Now during the demo, we'll be using a lot kubectl command, top command, and yeah, we'll see the CPU usage and memory usage using the kubectl command, which can be run against pods and nodes, and Now let's see a bit how we can do resource management in Kubernetes. Now it's, as developers, we have the possibility to put some limits into our pod definition file or deployment definition file. So of course we can skip those requests. We can skip those. We can deploy without those requests, resources requests and limits, but it is recommended to be used, and we'll see why is that. Now, those limits are defined at the container level, but it is useful to think of a pod as having those limits. Now, in the request, on the request side, we'll put the CPU minimum value for the pod to be used. Same applies for the memory. So under the request, we'll put the minimum values, and in the limits, we'll put the maximum value. Sorry, the maximum value, not the minimum value, as it is here. Now, it's also important to mention that the CPU resource is expressed in milliunits in Kubernetes, and there are some examples in here. And in Oracle, we have Oracle CPUs as a unit of measurement in terms of CPUs. And one Oracle CPU has actually 2 virtual CPUs. Now, memory request is expressed in bytes as an integer, and can be expressed using different suffixes. And we'll see in our deployment manifest file, we'll see this expressed in different kind of with different kind of suffixes. So there are multiple ways of expressing the CPU and memory requests, and yeah, that's the idea.
George, can I interrupt you for a second?
Yeah, please.
We were just discussing this, and you gave us a couple of questions that you said always come up, or nearly always come up when you're talking to customers on this. So just to, I know Marius and those are answering questions already, but just to raise these because people are sure to ask, right? So the first one you said that's really popular that comes up is what is happening. What is happening if we are requesting Kubernetes to use more memory than the node capacity?
Yeah, so this will actually will leave the pod unscheduled. So the pod will remain in pending status, and we'll see this in the demo exactly, because I have this scenario when we're requesting more CPU and memory than we have it available in our nodes. So it will remain in pending status, and the pod won't be scheduled.
Okay. And Violet, will I go?
I have one myself.
You got one? Okay.
Georgia, what is happening when pods use all resources up to their limits during the spikes or bursts of activity?
Now, it depends on what type of the resource. So what's happening on the pods, whenever the pod uses more CPU than the defined limit, the pod will be scheduled and the CPU is throttled, so it is suppressed. So the pod will be scheduled even if our performance may be affected. Whenever the pod tries to use more memory than the defined limit, the pod is actually, it will be finally killed. It's running out of memory, and yeah, this is what happens when we are trying to use more memory.
Thanks, George. Thanks.
Thank you.
Over to you now.
I'll let you go back. You can. We come back with the other couple of questions that you had later on, George. All right, back to you.
Thank you. So on the cluster side, cluster administrators can specify how much resources a pod can use, or to impose some limits using limit range, and can also restrict the requests and limits at the namespace level using resource quota. So there are some other constraints that administrators can apply to the nodes at the cluster level, at the namespace level. And those concepts are well explained in the Kubernetes official documentation with examples and different scenarios. So I'm not going into the details in here. I'm going to show you a bit how we put those limits. So let me stop sharing, and I will start sharing again. I hope that you can see my screen.
Yep, all good.
Okay, so now I do have some predefined pod definition files. As I said, those limits can be applied at the pod specification level or to the deployment level. And in this specification file, I have requests and limits applied for the memory resource. In this, I have limit request and limits applied for the CPU. And in this scenario, I have limits applied for memory and CPU. And I'm going to explain a bit what's happening. So let me first show you the cluster that I'm running on. So first of all, I should show you the way you can connect to the cluster. So you can easily connect to the cluster, and this is what I did. I copied this predefined prebuild command in order to connect to my Oracle Kubernetes cluster. And inside this container engine, I have two pools, and yeah, inside this pool, I have the worker nodes. So those are managed nodes, and are grouped together inside the cluster, and all of them are sharing the same amount of CPU and memory. This is one of CPU, as I was telling, it's equal with 2 vCPUs, and the amount of memory for each node pool is 16 gigs of memory. So this is the cluster I'm going to use for this demo, and those are the CPU and memory resources allocated to this cluster for each node. And I do have also another node pool, which I'm going to use for cluster autoscaler, and it's similar with the one that I was sharing with you. So going back to my code editor. So as I was showing, those limits can be applied at the pod level or at the deployment level, and I can check and I can show you what's happening if I'm, let's say, for example, if I'm asking Kubernetes to give me more memory that is actually defined into the limits. So if I'm doing this, let me save this first. So what I'm actually trying to do is I'm trying to use 3 gigs of memory, which exceed the limit that I defined in this pod specification file. So if I'm doing, first of all, I want to enable this. I just want to monitor what's happening with my pods in real time, and I'm using get pods white wedge, and now I can apply this. I think it's because it's running something. 1 second. Let's first make sure that I'm removing everything. Yeah, it's already running. That's why. Okay. It's deleted. I should see this in terminating status. I just tried a few minutes ago and I forgot to remove it. So if I'm trying to do again, okay, because it's not finished and I should wait a bit more. Let me remove everything in the meantime, just to make sure that I don't have any other in running status. Okay, now it should be fine. I will try again to apply this. Okay, I got the message saying that the pod has been created, and I can see that Kubernetes is trying to run this pod, but because it is actually trying to use more memory that we have defined into the limits, it's actually killed. So the pod is actually terminated. Now, the idea with the limits is to impose to make use of them during the burst. So that's the main utility using limits. So let me show you what's happening if I'm trying to. I will remove this for now. If I'm trying to use more CPUs than I have actually available in my node. And by the way, I forgot to show you how I can see the capacity of my cluster. So maybe it's deserved to go back again to the cloud and we say again that not the entire. So when we are defining here the CPU and the memory capacity for my worker nodes, that's the maximum amount that can be used, but not the entire CPU and memory can be used because there are some small processes, as I was showing, that it's running for Kubernetes components. So those components are consuming a very small amount of CPU and memory on each worker node. So going back here, if I want to see, I want to do a kubectl get nodes. So those are the nodes that I have it available in the cluster. And if I want to see how much CPU and memory can I use for example, for this node, I can do a kubectl describe node. And here I'm putting the node name. In my case, this is the IP address of the worker node. And inside this, I have a allocatable block, and that's actually the amount of the CPU and the memory that is available, and that I can use it for my pods, for my normal pods. I mean, yeah. So with this, what I'm trying to do now, I'm trying to ask Kubernetes to give me more CPUs that I actually have it available in this node. So it could be this node. I'm not sure if it will go to this node, but each node, as I was showing you, each node has the same amount of CPU and memory because it's sharing the same amount. Or all of them are put together in the node pool. So all of them are sharing almost the same capacity. Now let me save this, and if I'm going back to the pod CPU, and if I'm trying to apply this, okay, I got a message that the pod has been created, and what I can see is that it's in running status, and it's running on this node. And if I'm doing describe on this node, yeah, I copy it from here. Yeah, so what I can see is that yeah, I'm trying to look at the CPU limits request, and I'm seeing that the CPU request is 500 millicores. CPU limits is at 50%. And yeah, okay, the allocatable resources. Yeah, I think I should put more. 1 second. I'll remove it from here for the moment, and I'll try to assign more because what I want to do is to assign a higher limit. Yeah, I want to overcommit the resources on this pod. So if I'm trying to, let's say, put something like 5, sorry, I do have a limit. So sorry, I forgot about this. I'll try to put 3 CPUs here, and yeah, I will try to run it with 3 CPUs. Yeah. And if I'm trying to do again, to apply again, this deployment, I should be able to see. Okay, the container has started, and if I'm doing kubectl describe node and the node, okay, now I'm able to see the CPU limits are higher, so it exceeds the node capacity, but the pod is still in running status, and it's not killed or terminated. Okay, now what's the idea of having those? As you see here, in some scenarios I do have CPU requests, and in some scenarios I have memory requests and limits. Now in this scenario I have the same amount of CPU in the limits and in the request, so the requests are equal to the limits. The way we define the requests and limits will actually will give us the class of our pods. So in this scenario, if I'm assigning the same amount for the limits and requests, Kubernetes will consider this and will classify this as a guaranteed pod. And what will mean this will be considered as a high priority pod. So if I'm trying to apply this and I'm going back to the terminal, yeah, and if I'm doing kubectl describe for this pod, you'll see that this guarantee class is actually assigned to this pod. For example, if I'm looking to the other pods and do the same describe pod, I see that in that case, this pod is considered burstable. So the pods are considered burstable if they're actually the CPU, if we are defining request or limits, but the idea is that the value requested are different. So of course, for CPU and for memory in different scenarios. Yeah, so the class of the pod will actually, it's important when we have bursts of activity inside our cluster. So this will be taken into account by Kubernetes when the node will run out of capacity. So if the node will be under pressure, it will look to the class of the pods, and the ones that are considered burstable or best effort will be killed first, and the ones that are considered that are in the class guaranteed will be killed the last one. So it will be considered as having priority. Now I mentioned about the best effort class. The best effort class actually is assigned when we define nothing. So if we remove everything from here, yeah, and we leave this definition without having just having the container image and the name, and I'm trying to save this, and if I'm scheduling this pod, yeah, it's still running, so I have to remove it first. Okay, now if I'm trying to apply the changes and I'm looking at this, you'll see that in this case, in this scenario, this pod is considered is classified as best effort in the class best effort, meaning that this will be the first one that will be evicted when the pod is running out of capacity. Going back to my presentation, and because this is actually explaining here. So guaranteed pod are actually the pods that have requests and limits at the same value. So both of them are defined and are having the same value. Those are the latest ones that are will face eviction in case of the no pressure. The burstable are the ones that are will be evicted only after the best effort pods, and the best effort pods are actually the ones that we do not define anything in the request specifications. So neither limits, neither requests. Okay, now because cluster autoscaler is making scaling decision based on the request resource request from pods, it's important to get an idea about what does it mean, and that's why I explained this a bit more in details. Now, on the other side, the horizontal pod autoscaler and vertical pod autoscaler is making use of the metrics. So, as I was saying at the beginning, the idea of using autoscaler is also to make use efficiently of the compute resources. Compute resources like CPU, memory, and so on. So, but there could be also some other custom metrics. Because Kubernetes autoscalers are driven by metrics, we have to install the service metrics into our cluster. This is actually can be easily achieved if I'm going to the the first prerequisites that I have for using horizontal pod autoscaler is actually to install the metric server. So in my scenario, I already installed the metric server using some charts commands, or I'm just checking that it's running and it is deployed. Now in this example, I have a deployment, so a deployment specification file which is doing some compute is running some intensive CPU processing in here, and I'm actually simulating how the horizontal pod autoscaler works in the cluster. So the idea is that just to show you how it's working, and I'll keep this active, and because I already installed the service metrics, I can just deploy my application. Yeah, and I can check I'm already monitoring this. Yeah, I see what's happening in the background, and I can scale this deployment using a kubectl command, autoscale deployment, the name of the deployment, and I just have to specify the CPU percentage and the CPU percent, and I'm mistaken here, this should be 50%, and here I'm specifying the minimum, so the minimum amount, the minimum number of pods and the maximum number of pods. Now, if I can see that actually this pod is actually consuming a lot of CPU resource, and yeah, if I'm doing a kubectl describe pod, I can see how much of the resources is consumed or is allocated. Sorry, I have also some limits in here and the request. And in this case, because the limits matches the request value, this pod is considered guaranteed pod. So this can make use of exclusive CPU and memory. I forgot to mention about this. So if I'm trying to scale this deployment with horizontal pod autoscaler. Let's see what's happening. So cluster horizontal scaler is trying to scale this, but as you see, my CPU utilization is at 100%, so it will be impossible to achieve this target utilization of 50%. So because it's almost double, but it's trying to do this by increasing the number of replicas. So what it does actually, it's creating more and more pods. So horizontal scaler, it checks the metrics and sees that the CPU utilization is higher, and it's trying to achieve this utilization target by increasing the number of replicas. But in this scenario, it can't do this because it's using a lot of processing powers. This deployment is actually consuming a lot. Now, if you want, let's assume that I want to do some changes in my configuration. I can say that you can scale to the number of, let's see, 60 replicas. And in this scenario, I will be able to see a change. So it says that I changed the configuration of the horizontal scaler, and it's trying now again to achieve this target of 50% utilization. It will take a while to deploy all of the pods, and we should see it's creating more and more pods. Okay. As I was saying, so the horizontal pod autoscaler takes decision based on the metrics. That's why it's important to have these service metrics installed. Now, another thing is that horizontal pod autoscaler is offered out of the box, so you just need to do some configuration at the beginning, and it's running without anything else. Now, vertical pod autoscaler on the other side is actually is a plugin in OKE, and we have to install. We do some installations, but there are some sample commands, so I can show you how we can easily install it. Simple commands. So what we need to do is to make sure that the metric server is deployed, and we have to download the vertical pod autoscaler from the GitHub. I actually downloaded, so I can go back here and try to use vertical pod autoscaler. Now, the idea with the vertical pod autoscaler is that it is not increasing it's not increasing or decreasing. It's just increasing or decreasing the resources allocated to the pod. It's not changing the number of the replicas. Just 1 second to have a look on the chat. Okay. Now, when we can make use of the vertical pod autoscaler. So vertical pod autoscaler can be useful when, let's say, we have a database running on a pod, and we can scale a database so easily by adding more and more pods. So, but we can increase the capacity. We can change the limits of that pod so that the database can handle more connections. And it will it won't be affected. Now, for doing so, as we're saying, we have to install, we do some installation to deploy the vertical pod autoscaler, and in my scenario, I will install it. Is already installed, so I should remove it first. But because we are actually running out of time, I will skip those commands for now. I'm trying to, so what is important to check in here is that vertical pod autoscaler has some components like recommender, updater, and controller. So we'll see some additional pods installed on the and the recommender is the one that is actually doing recommendations. The updater will be the one that will do will change the values, and the controller will apply actually the recommended values. Now, if I'm pod autoscaler, so I have to go back and I have to apply to do again this deployment. And then I will check the CPU and memory that it is recommended by the vertical pod autoscaler. So I can, okay, it hasn't done any recommendation, but it will take a while to see. Okay, it's in running status, and I have 2 replicas. Yeah. So I should see. Okay, I will check later on. So what I can see, I will now is just the requests and limits that are assigned to the pod. But vertical pod autoscaler will give us some recommendations, and will actually apply those recommendations based on our specifications that we have in the deployment. So I just wanted to show you how it's working. I will go to the cluster autoscaler because we don't have too much time. And let me show you a bit how we can use cluster autoscaler. As I was saying, cluster autoscaler is making use of the resource requests from pods. And if there are pods which are in pending status, cluster autoscaler can take decision based on that. So let me share with you a documentation that it is important for using cluster autoscaler in OCI. So there are two ways. It's a standalone program that can be used, and there is also an add-on that can be also used for the cluster autoscaler. Now, I choose to use standalone program because it's more flexible, and there are some prerequisites in terms of assigning some permissions at the compartment level to use it. So I define those permissions, and the next step is to actually configure this cluster autoscaler YAML file. Now, let me open this file and share with you what it requires to be changed here. First of all, the image, the cluster autoscaler image will depend on the region. So we have to change the image path in here, and then afterwards we need to specify the node pool that will be used by cluster autoscaler to make to scale up and or down the worker nodes. So we define a limit in here saying that you can't scale less than 1 worker node, and that's the maximum limit. And this is the node pool ID that it is used by this in this configuration. So as you saw, it's recommended to use actually a different node pool for cluster autoscaler. So in a production environment, that's actually a good practice to use cluster autoscaler with a second node pool. Let's say if you have only one. And what I did, I actually copied the node pool ID from here, and I put the value of it in here, and I said that, as I said, can scale between 1 and 3 nodes, and that's actually all. To run this cluster autoscaler, so we have to connect to the cluster, of course, and we can deploy it using this manifest file, and then we can actually check if the cluster autoscaler has been deployed properly. Because I did this before, you can see that the cluster autoscaler, in my case, is running in the background, but it doesn't take any action to scale up or down because I didn't. It's not necessary. I have to deploy, stimulate, and to deploy more pods, and based on that, we can see how the nodes are increasing into our cluster inside this node pool. Now, as I told you, there is also the possibility to install the cluster add-on. There are less parameters in here, so the approach is very similar. You have to put the same minimum amount of value for the all core nodes, and the same the node pool OCID that you want to be used by the cluster. Any question about this? If not, I'll go 1 second. I will check again
all the questions has been answered.
Okay. Yeah, I see.
George.
Yeah. Thank you. Now, it's important to mention that in OKE, in Container Engine for Kubernetes, in OCI, we can use cluster autoscaler only with the managed nodes. So because I mentioned about the managed nodes, the difference is that in the managed nodes, we have more flexibility, we have more control over the worker nodes, and also we have the responsibility to maintain those managed nodes. On the other side, with the virtual nodes, you can also deploy Container Engine for Kubernetes on OKE using virtual nodes. The advantage is you don't have to care about the infrastructure management, the Kubernetes infrastructure management mainly. And this is actually, it gives you a serverless experience for using Kubernetes. And yeah, it can fit different kind of workloads depending on what type of deployments are you wanting to do in the Kubernetes. Now, I'm going to share with you those resources at the end of the session. We do have some the same documentation for each of the autoscalers, and we are also having a Kubernetes monitoring solution available onto the marketplace, which it may be very useful if you want to deploy the Kubernetes in OCI, and you can find it available on the marketplace. And you can easily deploy this Kubernetes monitoring solution in your cluster. I already installed it, so I can give you an overview about how you can use it. Okay. Region. So yeah, it may be very useful when you have multiple clusters or you have multiple deployments in your clusters. Yeah, okay, so it's working. So it helps you to monitor clusters, node status, the pods that are running. Yeah, you can do different kind of you can check different kind of metrics. Okay, now we do have some other services available in OCI, like container instances. If you do not want to care about the you don't care about the infrastructure part, and you want to you don't want to spend time on the infrastructure management, so container instances may be a good choice for to use as a runtime for containerized applications. I already talked about the virtual nodes, the managed node. You can also use your self-managed nodes, and we have also functions which are actually for deploying different kind of runtimes without us actually caring about the infrastructure. This is what I wanted to share with you today. If there will be interested, we can have a second session into the Kubernetes autoscalers, because there is more to discuss about this. And yeah.
Thank you, George.
Thanks, Al.
All right. With that, I would like to thank you all for joining us today. Thank you, George, for presenting. Thank you guys for answering all the questions. And we hope to see you again soon at Cloud Coaching. Thank you and enjoy the rest of the day. Bye-bye.